and welcome to this episode of Night Sky News for May 2025 with me, astrophysicist Dr. Becky Smethurst. This is the show where we chat about what you should look out for in the night sky in the next few weeks, and then we chat about what's been happening in space news in the past few weeks. In this month's episode, we're chatting all about the proposed cuts to the NASA budget, almost halving the space science program's budget, and what the potential impacts will be on astrophysics research. We'll also chat about the latest on the construction of the extremely large telescope in Chile, and chat about whether we finally spotted the infamous Planet 9 at the far edges of the solar system. There's chapter markers down here if you want to skip ahead to any specific news story, plus any scientific research papers I mentioned are all going to be linked in the video description down below, free to read. Also, a big thanks to KiwiCo for sponsoring this video, but more on them later. And so without any further ado, let's kick things off and start by looking up. Alright, as we get later into May, the nights are getting ever shorter here in the Northern Hemisphere, which is making stargazing a little bit difficult because we either have to stay up later or get up earlier for a dark enough sky. But the brightest objects are still visible in that glow that's left over after sunset or comes before sunrise. For example, the stars in the summer triangle, so Altair, Deneb, and Vega. These are rising in the east just after sunset and visible all night as they rise higher as the night goes on. They should even be visible all night now for the next few months or so through the summer. Now, this is not an official, defined and agreed upon constellation as such, because each of the three stars are in separate constellations. So Vega is in Lyra the Harp, Deneb is in Cygnus the Swan, and Altair is in Aquila the Eagle. So it's what's technically known as an asterism rather than a constellation, but this triangle of stars should be really easy to spot, even for those of you in the middle of cities, for example. So, when you're watching the sunset and the sky is just gradually getting darker and some stars are starting to pop out, these will be three of the first stars that appear after sunset. They are that bright that you can even be seen sort of during twilight. It's a real herald of summer for any astronomer, so see if you can spot them this month. So with the brightening skies in the Northern Hemisphere, the best stargazing opportunities this month come with the longer nights the further south that you are. Especially since we're getting into the peak season for spotting the Milky Way, our galaxy of hundreds of billions of stars which stretches out in an arc across the sky. In a dark sky, you can see the glow from millions of stars so far away that you can't make them out individually, but their light all combines together to give you that glow, along with the dust in the Milky Way as well, so heavier elements like carbon that have been pooped out by supernova when stars die. Now, because of the sun and the solar system and therefore Earth's position in the Milky Way, we're out sort of on the edge of the galaxy, in the suburbs, if you will. And the Northern Hemisphere has the best view looking out of the galaxy, which means it's not as dramatic, you don't see as many stars, but the Southern Hemisphere looks in towards the center, where you get the most dramatic view of the Milky Way, towards the constellation of Sagittarius, which is most recognizable by most as the teapot. But as well as that solar system tilt that means the Southern Hemisphere has the best view, we've also got the Earth's axial tilt as well, which means that the best view of the center of the Milky Way comes in the months in the middle of the year, with the center of the Milky Way rising just after sunset and visible all night at the moment for those far enough south. Here in the UK and around similar latitudes, the sky is just too light and the center of the Milky Way doesn't rise high enough above the horizon at this time of year to be able to see it. The best time for us is sort of August time. But for those around the Tropic of Cancer and further south, you should have the best chance if you look up towards the south, but do give your eyes time to adjust, at least 15, if not 20 minutes, because you're trying to detect something incredibly faint. And if you've just been looking at the light inside your house, which is incredibly bright, then your eyes are not going to be adjusted to pick out that faint glow of the Milky Way. Remember that with any long exposure shot with your phone or your camera, the Milky Way will always appear stronger than what you can see with just your naked eye, in real time. So if you are struggling to pick out where it is, just grab your phone, take a quick long exposure in what you think is roughly south, and see if your phone picks up something so that you then know where to look as your eyes adjust. But make sure that your phone brightness is turned way down, and you do it early on as well, so that again you've not ruined all of that sort of adjusting your eyes have done to the darkness by absolutely blaring them out with your bright phone screen. And if you want to try your hand at some astrophotography, I have a video with beginners tips for you if you want to check that out. But if you do have lighter skies, then don't worry, you can still catch the very bright planets at the moment as well. This is something that can be seen worldwide, at least if you're below the Arctic Circle, where you're going to have permanent daylight for the next couple of months. But as long as you still get a little bit of twilight at least, you will be able to see some of the bright planets. So in the morning skies right now, we have Venus and Saturn rising in the east a few hours before the sun does. Venus is the brightest thing in the night sky after the moon. So this should be fairly easy for you to spot. It'll be the one slightly lower down towards the horizon before the sunrise and that fainter yellowish Saturn above it. Now, thankfully, you can also use the moon as a signpost of where to look. So my personal favorite moon phase, the crescent moon, aka the toenail moon, will swing past them on the nights of the 22nd to the 24th of May. So on the 22nd, the moon will be closest to Saturn. On the 23rd, it will be between them. And then by the 24th, it will be below Venus. This is also a great time to try and spot Venus in the sky because on the 1st of June, it reaches what's known as its greatest western elongation. Essentially, the furthest it gets from the sun from our perspective here on Earth, and therefore the furthest it gets from the sunrise. That means it rises higher in the sky before the sun rises behind it, making it easier to spot. Now, if you aren't particularly a morning person, then you should look out for Jupiter and Mars just after sunset in the evening. Jupiter is the brighter of the two, but it is quite low on the horizon at the moment, so this will be easier to see the further south you are, whereas the fainter, slightly reddish Mars will be higher and easier to spot, sticking around much longer after sunset. Again, if you're not sure what you're looking at, then wait for the moon to signpost you, because on the 28th of May, it will be a tiny sliver of a crescent near Jupiter before sweeping upwards in its orbit past the twin stars in Gemini, Castor and Pollux, before coming closer to Mars on the 31st of May and the 1st of June. All right, that's it for what to look for in the night sky for this month. But before we chat about what's been happening in space news, I know a lot of you watching have kids that are also interested in space and astronomy, because I get a lot of questions on, how you can best nurture that curiosity at such a young age. And honestly, one of the best resources that I've found to keep that spark alive in kids is KiwiCo. Before they reached out to me, I'd seen so many people online talking about KiwiCo, and now I've had chance to actually try out some of their crates. I really wish that I'd had this as a kid. KiwiCo creates hands-on STEM projects that make learning fun, like building your own robot or launching a mini rocket. With KiwiCo, a new crate arrives at your door each month, packed with a new project designed by experts and kid-tested, so you know it's the perfect mix of educational and exciting. This month I got to try out their astronaut starter kit, which is designed for ages 5+ and teaches them about the solar system and rocket science, all while letting their creative juices flow. I loved how clearly it explained the science behind rocket launches in a fun and digestible way. It just keeps kids engaged, challenged, and off their screens. I can only imagine how fun this would be to do as a family. At least this big kid and her cat definitely loved it. And the best part is that KiwiCo offers monthly crates for every age and interest, whether you've got a budding scientist or a young inventor or a creative artist. There's just something for every curious kid or kid at heart. So if you're looking for ways to fuel your kids' interest in science and give them hands-on learning experience, I highly recommend KiwiCo. And if you want to support my channel at the same time, you can click the link in the description or use my code AstroDrBecky for 50% off your first monthly crate. So a big thanks to KiwiCo for supporting this channel and for making these awesome kits for young scientists. And now let's come back down to Earth and chat about what's been happening in space news in the past month. All right, well, the big news this month came from this research paper by Medusadan and collaborators that claimed to have found a detection of the molecule dimethyl sulfide in the atmosphere of the exoplanet K218b using the James Webb Space Telescope, JWST. And dimethyl sulfide is a molecule that, on Earth at least, is only produced by microbial life. That's the only type of chemistry that we know produces it. Biochemistry. So this was such big news that I already made an entire video on it with a deep dive on this, explaining in that video how no, we have not found evidence for alien life yet, at least. And that's because, first of all, the detection itself doesn't have very strong evidence in support of it. Plus, we've already seen another research paper released claiming there's no evidence for a detection in the data from JWST. And secondly, even if there is a detection of dimethyl sulfide in the atmosphere, orbit of this planet. That doesn't necessarily point straight to life, just because we see it produced by life here on Earth. Dimethyl sulfide has been found on Mars, on comets, and in the gas in between stars as well. Just because the only current way we know of to make dimethyl sulfide is through biochemistry, through life, doesn't mean there's not some unknown chemistry, unknown to us, that's going on that could produce dimethyl sulfide in the atmosphere of this planet that is very different to Earth. It's somewhere between like Earth and Neptune. There's still a lot of debate about whether it is like a super Earth or a mini sort of gas giant planet. So if you want more info on this, check out my previous video, but otherwise the takeaway is no, we haven't detected life out there in the universe beyond Earth. Not yet, anyway. One thing us astronomers are celebrating this month, though, is that the European Southern Observatory's extremely large telescope, the ELT, has now reached its highest point during the construction, with the structure of one of the dome's sliding doors now fully installed. It's so wholesome, right? The team had this like barbecue to celebrate this at the construction site atop Cerro Armazones in Chile, in what's known as a topping out or roofing ceremony, where both the European Southern Observatory and Chilean flags were raised atop of the telescope dome. It's a big milestone, with that whole construction project now over 60% complete. When construction is completed, which is set currently to be 2026, the ELT is set to be the largest eye on the sky, with a 40-meter wide mirror to collect and focus the light from distant stars and galaxies. That's 4 times wider than any telescope we've had before. The current record holder is the Gran Telescopio Canarias, the GTC, in the Canary Islands, which is 10.4 meters across. Now, ELT is going to be a telescope that's useful across all research areas in astronomy. I included it in my video where I listed some of the next generation telescopes that people are most excited for. I'll link that below if you want to check that out. Personally, I'm more excited about the ELT coming online than I was about JWST, and that's purely selfish reasons, right? The instruments on the ELT are much more relevant for my science research as opposed to the instruments on JWST. However, the ELT's science capabilities, along with all the other telescopes at nearby sites, which are currently the best in the world to do astronomy from, are under threat from a proposed green energy industrial project. The proposed site for this project is just 11 kilometers away from where the VLT, the Very Large Telescope, is now, and it would increase light pollution by at least 35% above the current levels there. The ELT is 20 kilometers away from the proposed industrial sites. There will be less of an effect there, but it is still in danger from increased light pollution, preventing science from happening. So ESO are working with all the parties involved to determine a solution. There's also been an urgent call letter to the Chilean government that's been signed by me and over 3,300 of my colleagues to get them to reconsider the location of this green energy project, just to try and protect some of the darker skies that are left to us here on Earth. So a lot of sort of science adjacent politics in this video, but let's take a break from politics for now and chat about this paper by Fan and collaborators, who claim to have found a candidate for the infamous Planet 9. Okay, so Planet 9 is the currently hypothetical planet that people have claimed must exist out beyond the orbit of Neptune, like we're talking way beyond Neptune, way even beyond Pluto, to try and explain some of the weird orbits that objects have out there. So, you know, other lumps of rock we probably dub sort of asteroids, but we call trans-Neptunian objects. And we found that these objects have these really weird clustered orbits that we've not been able to explain yet. Now, there's a few ideas for what could be causing this, but one of the leading hypotheses is that there is another planet that we haven't found yet, that's somewhere around 5 to 10 times heavier than Earth, that is essentially shepherding all of these other objects into these weird and clustered orbits. But the existence of that planet is still completely hypothetical. We have no observational evidence to support its existence yet. If it did exist, it would be really hard to spot. First of all, because of how far away it is, it would be incredibly faint. And then second of all, because of how large its orbit would be around the sun and how long it would take for it to do one orbit around the sun, it would be really, really slow moving on the sky. So it would hardly appear to move against the fixed position of the background stars, which is how we detect a lot of asteroids and distant trans-Neptunian objects in our solar system. Optimistic simulations of Planet 9 suggest that if it did exist, it would move around about 0.05 degrees on the sky every year. Just to put that into context, the moon is half a degree across, so it would only be 10% of the moon's diameter each year. Now, I've covered this idea before on my channel, including an even crazier idea that Planet 9 could be a black hole, and that's why we haven't spotted it yet, despite many searches in surveys of the sky that have been done looking for something that moves. So what Fan and collaborators have done is use two infrared surveys of the sky, IRAS and Akari, which are taken 23 years apart to look for things in the sky that have moved. So IRAS was taken in 1983 and Akari in 2006 to 2007. So infrared, first of all, is a good avenue to go down because, okay, yeah, it is so far away, it won't reflect a lot of visible sunlight, but it will be, you know, like a warm object, so it will be radiating infrared lights that can add to the amount of light we should be able to detect. And then the fact that there's 23 years separating these surveys is also a really good idea as well, because if you can compare the same patch of sky taken, you know, at one time period and then 23 years later, if this planet is incredibly slow moving, then after 23 years, that movement will accumulate and hopefully we should be able to spot something. So to narrow down the candidates from these really large surveys, they took estimated ranges of the size, the orbit, and the temperature from like simulations of Planet 9 and worked out how bright they'd be in the surveys. So then they looked for things in those ranges that had been spotted in one survey, but not in the same place in the other survey, just like have moved sort of, you know, the expected amount, say like less than a degree in the sky in that time frame of 23 years. They found 13 candidates, but after inspecting the images, confirmed that only one of those 13 actually didn't have detections in the same place in both surveys. And it had moved about 0.78 degrees across the sky in the 23 years between the two surveys. So it's definitely a slow-moving object, whatever it is. Now, is this actually Planet 9? Well, the authors don't really know, and they never claim that what they found is Planet 9 because, you know, the number of candidates they find is like massively heavily dependent on what they assume in terms of like the size and the mass and the temperature and even how much it could have moved in 23 years as well. If they relax those constraints, they end up with way more candidates. And the annoying thing is with only 2 data points, you can't derive an accurate orbit for the object you've found either, because like the noise on those 2 data points mean there's a whole host of different orbits that you could fit. So Fan and collaborators are planning to get more observations of this object using the DE-CAM imager on the 3-meter Blanco telescope in Chile in the hope of observing it again nearly 20 years later in the place you might expect it to be if it continues to move at the same rate across the sky. If they confirm that it is still there, then we can start talking about whether this is Planet 9 or not and what the data suggests for what its properties are in terms of its size, and would it be able to actually shepherd all these trans-Neptunian objects into these weird clumpy orbits. Until then, though, this research paper just remains an interesting curiosity that I'll be keeping an eye on, and I'll report back on this channel when we know more. But now, we can't ignore it any longer. Let's talk about the proposed cuts to the NASA budget and its potential impact on astrophysics research after the release of the presidential budget request for 2026. So this is a process that happens every year in the US's government system. So it starts with the White House, which is the US's Executive Office of Government, and they propose a budget for all government spending for the year, which includes NASA because it is a government-funded space agency. That budget then has to get voted for and passed through their Congress, so the part of their government responsible for making laws, before the president will then sign it into action. Now, there are lots of rumours coming out through the month of April that there were going to be cuts to NASA's budget that seemed excessive and people hoped were completely unfounded rumours. But on the 2nd of May, the White House published what's known as the skinny budget. It's a document that acts like a blueprint rather than a binding legislation, and it just signals what the current government wants to enact in terms of the budget. And it was there that we had confirmation of a 24% cut to NASA's overall budget. Now that cut is not overall on all programs. It was actually technically good news for human space exploration, which saw an increase in the budget with an extra $647 million going towards the goal of returning humans to the moon before China does, and also putting humans on Mars. The bulk of the cuts hit the space science programs, with a decrease in budget of $2.265 billion, a 44% cut to the budget in comparison to the 2024 budget for NASA, and an over 50% cut to the Earth science budget. So Earth science being the study of Earth, right? So yes, earthquakes and volcanoes, natural disasters, things like that, but also climate and weather. Whereas the space science header here covers astrophysics, heliophysics, and planetary science. We don't know for sure yet how that 44% budget cut will be split across those three, astrophysics, heliophysics, and planetary science. But in the leaked documents that came out in April, they suggested that astrophysics would be the worst hit, with over 2/3 of the budget gone. So what impact would that have in terms of science, what we're going to learn in the next couple of years? Well, the skinny budget specifically names the Mars sample return mission as being completely cancelled. So that's the joint NASA and ESA, the European Space Agency's mission, to send a probe to collect the rock samples that were drilled by the Perseverance rover on Mars in the past couple of years and bring them back to Earth. The budget instead wants to invest in sending humans to Mars, and they point out that, okay, well, if you've got these rock samples on Mars, then humans can just bring them back to Earth instead. Now, the skinny budget doesn't go into any more detail on what's going to get cut, beyond stating that they will reduce lower priority research and terminate unaffordable missions. But again, with the leaked documents back in April and the history of sort of what's been funded in NASA, we have some idea of what's going to get cut. So the Veritas mission to send an orbiter to Venus to map the surface of the planet Venus in high resolution, that's already experienced some delays, so it's very likely that it's just going to get outright cancelled. But also the Da Vinci mission to Venus to send a probe into the atmosphere itself to study the chemistry, that's likely to get cancelled. I was particularly excited for that one because if you remember, that was the mission that we were going to use to test, is there phosphine in the atmosphere of Venus? Phosphine being another one of those molecules that's produced by microbial life here on Earth. And we were going to ask the question, okay, well, is there actually, life producing this in the atmosphere of Venus, or is it some unknown chemistry? But the one that hits the hardest is the rumours that the plan is to kill the Nancy Grace Roman Space Telescope, which has already been built, right? All of that money has been invested. It is due to launch in 2027. But with this budget, it's likely that there's not going to be any money to continue to support, all the testing that has to be done, and then the launch itself, and then also like the mission's operations, like the actual day-to-day running of the telescope once it's in space. Now, thankfully, it's very likely that like the Hubble Space Telescope, for example, and the James Webb Space Telescope, JWST, they're still going to be supported in terms of the everyday running costs of those telescopes. So nothing to worry about there. But Roman was supposed to be Hubble's successor. I know people said that for JWST, but it looks in infrared and not visible light, whereas Roman is visible light. It truly is Hubble's replacement. So while I really hope it doesn't get cut, because that would be a waste of all of the investment that's been put in the past couple of years to even build the thing, I just don't see how this can happen under the budget that has been proposed. I can also imagine that, for example, the Hubble Space Telescope gets decommissioned earlier if it comes down to a choice of keeping Hubble running or keeping JWST running. And it's also likely that the X-ray telescope Chandra will get cut as well. If you remember, there was the Save Chandra campaign from last year. It is still functional as a telescope up there in space. It just needs continued to support, to continue the ongoing, day-to-day running of the telescope and taking observations. That's not likely to continue now. And then, of course, with all of these missions getting cut, there's no need for NASA's Goddard Space Flight Center in Maryland either, where you've got 10,000 people employed. And it puts the future of JPL in California in doubt as well. So yeah, it's not just astrophysics that we have to be worried about. If you were excited for the Artemis missions, for example, to, take humans back to the moon after so long, well, a lot of those are getting cut as well. They'll be keeping the Artemis 2 and Artemis 3 missions. So Artemis 2 is going to be sort of like launching the astronauts in the Orion capsule with the SLS rocket to test that. They'll loop around the moon and return to Earth. Whereas Artemis 3 will do the same but actually land humans on the moon. There was then a whole slew of follow-up return missions of putting humans on the moon for science experiments and testing and construction of the Lunar Gateway, a space station around the moon. But those follow-up Artemis missions are going to get scrapped. Lunar Gateway is going to get scrapped. And despite all of the time and effort and money that has gone into developing the Orion capsule and the SLS rocket, which was NASA's heavy launch system to get things beyond an Earth orbit, they're all going to get scrapped as well in favour of developing a whole new system to take humans to Mars, presumably doing that by working with commercial space companies. Plus, the entire STEM engagement budget is completely gone. So all the amazing work that NASA does to engage the public and produce lesson plans for teachers and produce like graphics and visuals to explain new concepts and new discoveries, all that is gone. So yes, as an astrophysicist, this budget is obviously so downheartening to read. To me, reading this, like, it doesn't read like this budget is driven by the desire to learn as much knowledge as we possibly can. It isn't driven by science. It's driven by politics, right? The recurring theme here is beating China back to the moon and then putting humans on Mars. Now, you could argue that this is a very similar situation to the 1960s, right? During the space race, when the US was trying to beat the Soviet Union to space milestones, and eventually they succeeded in landing on the moon in 1969. This was a golden age for NASA, right? It led to inspiring so many people to do PhDs in science and engineering, and it led to new technologies and materials being developed that were beneficial to society. But at the time, that's all NASA was. It was a space exploration agency with the science and the research left to universities and research institutions. But with the advent of space telescopes and missions to planets and satellites to study the Earth and the Sun, NASA became so much more than that. It became a world leader in space science, and so many projects and so much science was enabled by NASA that is still true today. And now it feels like all of that is in danger. You know, this is not just impacting the people who work at NASA. You've got people at the European Space Agency who work on joint projects with NASA, wondering if their entire, research and life's work is just going to get scrapped in the next decade. Everyone is just in limbo right now. And I guess this is unsurprising given the America First ethos of the current administration. And I know there are going to be so many comments on this video just saying, just talk about science, don't talk about politics, keep them separate, because every time I talk about politics on any social media platform, that's what I get. But I just think this is a really clear example of why you can't do that. And the funny thing is, a lot of us scientists don't even want to put humans on Mars because of the contamination risk. If you want to know, was there life on Mars in the past when we think it was more habitable because it had liquid water flowing on its surface, then if you've put humans on Mars and then you find evidence for that, there's always going to be this doubt, right, about whether what you've actually found is just contamination from the presence of humans on Mars and not evidence for past life on Mars. This is what I meant, right, when I said this budget doesn't seem to be driven by science. To me, it's very telling if you read through the lines here on working with commercial space companies to achieve all these new goals that have been outlined, what this is driven by. Who in the current government or is advising the current government stands to make money out of this? So what now? Is all hope lost for future science research at NASA? Is this the extinction level event that it has been dubbed? Well, we will know more details in late May when the full budget proposal will be published. And then it's got to go through their Congress, where it's expected there's going to be a lot of pushback on both sides of the political spectrum from both parties in the US. If you are in the US and you don't want to see NASA's budget cut in this way, you can make your voice heard by writing to your member of Congress. The Planetary Society have collected a load of resources to help you do that, which I'll link below. I'll also link this skinny budget document that was released by the White House, which details not just cuts to NASA, but other science agencies such as the National Science Foundation and the Department of Energy. For now, though, we're just in that weird sort of limbo of a wait and see what happens in terms of the final approved budget, which might not even come until next year yet. And then after that, we'll just have to respond to the ripple effects that creates. But for now, just to all of my colleagues out there that are on some form of NASA funding or a NASA grant or employed at a NASA institution, I'm thinking of you. I'm sorry that you're in such a really crappy situation, and let's just all just keep our fingers and toes crossed that these cuts aren't quite as bad as this skinny budget would like it to be. All right, well, on that depressing note, that's it for Night Sky News for this month. As always, if you see any space news stories that you want me to explain in a future Night Sky News episode, or if you snap any pictures of the night sky that you want to share with me, then tag me over on social media because I always love to see those. Until next time, everybody, though, happy stargazing. By looking up. A crack in my ceiling that I've not noticed before. There's a motorbike outside. I will wait. Armazones. Cerro Armazones. Is that how you pronounce that? I've never actually said that out loud before. I presume it's like a Cerro Armazones. I never actually took Spanish or Portuguese. I don't know. See, I don't even know.
Cerro Armazones.
No. Space Flight Center in Maryland, where you've got 10,000 in Maryland. Sorry, I say Maryland and I know it's Maryland. Oh my god, I've done this whole thing without my lights on. I just realized I've done the whole video without turning these two big lights on that I have here. They've just been off. All I've been lit by is the skylight, and I just noticed because the sun went in behind a cloud. Okay, well, this video is lit how it's lit. Can't change it now.